Good morning. It's May 25th, and this is your daily brief in science. Here's everything you need to know. A post-COVID rise in hip arthritis and avascular necrosis among younger adults is raising alarms at the Delhi Hip 360 conference, tied to prolonged steroid use during the pandemic and a surge in demand for total hip replacements. Experts stressed that early diagnosis and joint-preserving treatments are crucial. With increased awareness, timely magnetic resonance imaging evaluation, and prompt medical consultation able to reduce disability. Advances in robotic-assisted surgery, minimally invasive techniques, and better implants are supporting faster recovery after hip replacement procedures. The conference, organized by the Delhi Orthopedic Association with the Indian Arthroplasty Association, was held at Crown Plaza, New Delhi. Younger patients are increasingly affected by AVN and hip degeneration, with obesity, sedentary lifestyles, alcohol use, and metabolic disorders contributing to the trend. Without strengthened early screening and preventive orthopedic care, India may see a sustained rise in hip replacement demand over the next decade, necessitating ongoing surgeon training and adoption of modern arthroplasty techniques. Public health implications emphasize awareness, responsible steroid use, and prompt orthopedic consultation to avoid a large rise in future demand. Experts warned that a sustained increase in hip replacement demand could occur if preventive care and early screening are not improved. Duke University School of Medicine researchers are pursuing a new approach to chronic nerve pain by restoring healthy mitochondria in nerve cells, not just blocking pain signals. This strategy aims to fix the underlying energy deficiency in neurons and glial cells, offering a mechanism beyond traditional analgesia. The key finding centers on MYO10, a protein essential for forming tunneling nanotubes that move mitochondria between cells, pointing to a precise molecular target for future therapies. In mice, increasing mitochondrial transfer between cells reduced pain-related behaviors by up to half, suggesting substantial potential for energy-sharing therapies. Satellite glial cells were found to transfer healthy mitochondria to sensory neurons via these nanotubes, a process whose disruption is associated with nerve degeneration and pain symptoms. Disruption of this mitochondrial transfer may contribute to nerve deterioration, highlighting the importance of healthy intercellular energy exchange. Direct injections of healthy mitochondria into the dorsal root ganglia reduced pain, while mitochondria derived from diabetic donors did not provide benefit, underscoring the importance of mitochondrial quality. The effectiveness depended on mitochondria being healthy, with diabetic-derived mitochondria failing to relieve pain. Researchers emphasize the need for advanced imaging and further work to visualize mitochondrial transfer in living tissue before translating findings to clinical treatments. Future studies should clarify the nanotube-mediated transfer mechanism and develop imaging tools to observe delivery in real time, guiding potential therapies for chronic pain. A new wave of fake citations is surfacing across science, not in isolation, but across hundreds of papers and major databases. A collaboration between Cornell, UCLA, and UC Berkeley found roughly 150,000 fabricated references entering scientific records in 2025, with many moving from preprints to peer-reviewed journals. Across Arxiv, Bioraxiv, SSRN, and PubMed Central between 2020 and 2025, researchers checked references against Semantic Scholar, OpenAlex, and Google Scholar, and found a large share could not be verified. In total, about 1 in 2,800 papers in 2023 contained at least one fabricated citation, rising to 1 in 450 in 2025 and 1 in 277 by early 2026. A Lancet audit of 2.5 million biomedical papers shows a sharp rise in fabricated references, with more than 4,000 fake citations across 2,810 papers from 2023 to early 2026. The spread isn't limited to one field. The study notes AI-produced fake citations infiltrating biomedical literature and broader science, highlighting verification gaps. The surge is linked to the shift of AI tools from writing aids to citation generation engines around mid-2024, driving a proliferation of hallucinated references. An analysis of 111 million references from 2.5 million papers found many unmatched or non-existent citations after large language models became widespread. The problem extends into how citations are used in clinical guidelines and systematic reviews, prompting publishers to call for automated reference verification before acceptance. RxIVy has announced steps to ban authors who submit work with hallucinated citations or unvetted AI content as part of CURB efforts, signaling a push for stronger safeguards. Overall, the findings emphasize that AI-generated fake citations are spreading across scientific literature and increasing the need for robust verification and monitoring measures across publishers and platforms. A single common mechanism underlies hundreds of different cancer mutations, offering a potential universal target for therapy. A Nature paper introduces PerturbFate, a platform that tracks how genetic changes reshape cell function and identifies key dependency points across a wide range of mutations. The study finds that diverse mutations funnel into a common survival mechanism mediated by a mediator complex, with the VEGFC molecular signal acting as a central node for drug resistance and tumor growth. To validate PerturbFate, researchers tested chemotherapy-resistant melanoma cells by selectively disabling 143 genes and analyzing DNA accessibility and new RNA synthesis to map gene regulation. Blocking VEGFC in melanoma cells caused rapid loss of drug resistance and halted tumor growth, demonstrating the potential for a universal treatment strategy targeting the tumor's shared survival pathway. The researchers suggest that future cancer therapies could focus on disrupting this shared mechanism rather than targeting each individual mutation, potentially improving outcomes for aggressive cancers. Overall, the findings point to a single common mechanism that underpins diverse cancer mutations, highlighting VEGFC as a central node and suggesting a universal target for therapy. A new science study shows warming temperatures in the Himalayas are driving faster river movement, with glacier melt and permafrost thaw intensifying sediment flow and weakening riverbanks. The research analyzes 1,079 bends across about 1,582 kilometers of Himalayan channels from 1980 to 2020, using satellite imagery and field observations to map migration, bends, cutoffs, avulsions, and shifting channel patterns. Conducted across 3 major Himalayan basins, the multinational worklinks observed river dynamics directly to climate-driven changes in glaciers and permafrost. The study, published May 14, 2026, notes overall river migration rates rose roughly 33% over the period, with freely moving bends nearly doubling in frequency to about 97%. It also documents increases in cutoffs, avulsions, and broader changes in channel patterns downstream. Researchers warn these accelerated dynamics could affect billions who rely on Himalayan water, stressing the need for climate-informed planning. The team is led by Professor Chengshan Wang and Dr. Zhongpeng Han, with Dr. Lin Zhipeng and collaborators from multiple institutions, including China University of Geosciences, Beijing, and Sichuan University. The study emphasizes integrating climate-driven river changes into long-term water management, flood control, and infrastructure planning across the Himalayan region. This has been your Daily Brief in Science. To read more about these stories, follow the links in the episode bio. You can also subscribe to these updates via email at www.brief.news. For more daily podcasts about the topics you love, visit brief.news/podcasts. Tune in tomorrow. We'll be back with everything you need to know.